Okay, so we're diving into Venus this time. You sent us a whole bunch of articles about it.
We did.
And actually, the more I read about Venus, the more I'm like, wow, this is a fascinating place.
It's a fascinating planet.
It's like right there. It's like our neighbor.
Yeah, it's Earth's twin. Well, so they say. I mean,
that's what they say, right?
But isn't it?
I mean, you know, it's pretty clear that it's not exactly like, hey, let's go spend the weekend on Venus. Right. It's not exactly
toasty.
It's a little more than toasty. It's a lot more than toasty.
Right. Yeah. We're talking surface temperatures that can melt lead.
Oh, yeah. Yeah. Like, forget about it.
Yeah.
Forget about it. You're not going there. But I mean, just to set the stage for folks, I mean, when we talk about Venus today, we're talking extreme heat, like you said, this incredibly dense atmosphere.
Yeah. 90 times thicker than Earth's atmosphere.
Yeah.
Mostly carbon dioxide.
Wow.
Which is like wrapping yourself in a down comforter on a summer day.
Yeah. No thanks.
Yeah.
But here's the thing that I find really interesting, and I think a lot of people listening probably have heard this, but it always blows my mind to think about this. Scientists believe that Venus might have once been a very different place. Like literally.
It might have.
A completely different place.
Yeah. We're talking liquid water oceans, potentially, for billions of years. Maybe even longer than Earth had them.
That is wild.
That is wild.
That is wild. So you're talking about a place that is just a complete inferno.
Yeah.
But it could have been like this tropical paradise at one point.
Yeah. Maybe.
Yeah. And we're trying to figure out what the heck happened.
We are. That's the question, right?
Right. What happened?
Yeah.
And now India is getting in on the action here. They've got their Venus Orbiter mission.
That's right.
VOM.
Yeah,
and
catchy.
And they're planning to get there before NASA and the European Space Agency with their missions. I mean, that's a pretty bold move.
It is a bold move.
Yeah.
But, you know, ISRO, the Indian Space Research Organization, they're kind of known for this. I mean,
they got to Mars on the first try.
On the first try. They're good.
Which is amazing.
Like, that's hard. Like, that's not easy to do.
No.
So I think that they're a force to be reckoned with here.
Yeah. So it's interesting, though, because they're trying to get there first.
Yeah.
But it seems like all these different countries are kind of working on this together, which is cool.
Yeah, it's less of a race and more of a we're all in this together type of thing.
Like a collaborative.
Yeah. Like we're all trying to solve this mystery. So you've got India's VOM, you've got NASA's Veritas,
right,
and you've got the ESA's Envision.
Yeah.
And they're all kind of working together to be like, all right, what is the deal with Venus?
It's like we all brought our own instruments to the party.
Right.
Let's figure this out.
Exactly. And by bringing all these different instruments and all these different perspectives, we get a way more complete picture of what's going on.
Yeah. So it's interesting because we're talking about a planet that's completely shrouded in clouds, right?
Yeah.
So how do you even begin to see what's happening? And the articles mention radar is a biggie here, especially for the VOM mission. So talk to me about radar. What is that? And how does that even work on Venus?
So, yeah, you can't just like point a telescope at Venus and be like, I can see what's happening.
No.
It's like you said, it's completely covered in clouds. It's really thick clouds.
Right.
So what radar does is it's kind of like echolocation, you know, like bats.
Right.
So they send out these radio waves.
Okay.
They penetrate the clouds. They hit the surface of the planet and they bounce back.
To the spacecraft.
To the spacecraft.
Okay.
And then scientists can look at those radio waves and be like, okay, this is what the surface looks like.
So they're basically using those rebounding radio waves to like paint a picture.
Paint a picture, yeah. Like a three-dimensional picture of the surface.
That's incredible. And VOM is going to have a really good radar system, right?
Really good.
Yeah?
Even better than what NASA had back in the 90s with Magellan.
So we're talking high resolution here.
High resolution.
Wow. What kind of things are they going to be looking for with this radar? I mean, what are they hoping to find?
So they're going to be looking for things like mountains, valleys, volcanoes.
Okay.
All the different features. But they're also going to be trying to find evidence of past water, like those riverbeds that we were talking about.
Right.
So if they can find those riverbeds, that's like a huge clue.
That means there was water.
There was water.
Like literally
flowing water on the surface.
On the surface, which would be crazy.
It would be revolutionary. I mean, one of the big questions that they're trying to figure out is if Venus ever had continents.
Continents, okay.
Like Earth.
Like Earth has continents.
Right, because on Earth, continents are made up of granite.
Okay.
And granite needs water to form.
Got it.
So if they can find areas of Venus that have a similar composition to granite, that's a really good indicator that there was some serious water action going on.
Okay, so that's amazing. We've got the surface. But wait, it gets better, right?
It does.
VOM is going to be looking under the surface, too.
Under the surface. We're going deep.
Yeah. What is that about? Like, how do you even look under the surface of a planet from space?
So this is where it gets really cool. They have this thing called the subsurface sounder.
A subsurface sounder. Okay.
That's like an ultrasound,
Okay.
but for a planet.
I like it.
So it sends out these radar pulses.
Okay.
Some of them are reflected back from the surface, like we just talked about with the radar.
Right.
But some of them go through.
They go through. What do they hit?
They go through the surface,
Okay.
and then they hit like a boundary, like a different layer of rock or something.
Oh.
So they kind of like penetrate down in,
Okay.
and they hit something, and they bounce back.
They bounce back up.
And then that's what the sounder detects.
That is so cool.
Isn't that neat?
So they can see different layers of rock.
Different layers of rock. They can see if there are like old lava flows,
Oh.
maybe even buried impact craters.
Mm.
Like imagine a crater that's been covered up by like millions of years of lava and stuff. They can see that. It's crazy.
That is amazing. So they're basically like mapping the planet's skeleton, right?
Exactly.
Layer by layer.
Layer by layer.
And that tells us what does that tell us? Why is that important?
That tells us about Venus's history,
Mhm.
like its geological history.
Right.
So for example, if they find a lot of impact craters,
Yeah.
that might suggest that Venus got hit by a lot of asteroids early on,
Right.
like way more than Earth did. Or if they find like these weird distorted layers of rock, that might be evidence of past volcanic activity.
So it's like they're putting together this puzzle
It is a puzzle.
of how Venus came to be Venus,
Exactly.
which is so cool. And it's not just about what's on the surface and what's under the surface.
Yeah.
VOM will also be studying Venus's atmosphere,
Oh yeah, the atmosphere is a whole other ballgame.
which is just as extreme, right?
Yeah, just as extreme. We're talking sulfuric acid clouds,
Yeah. No thanks.
crazy high pressures.
Yeah.
You would not survive very long.
Like if you could magically transport to Venus, you would be
There'd be a pancake.
a very flat.
Yeah, very flat, very quickly.
Yeah. Squished. So how do you even study an atmosphere that intense? What are they looking for?
Well, one of the things you're going to be looking for is water vapor.
Water vapor.
Because remember, we were talking about the possibility that Venus used to have water.
Right.
So if they can find evidence of water vapor being released from volcanoes, for example,
Okay.
that lends more evidence to that whole idea.
So volcanoes could hold the key to Venus's watery past. That's fascinating.
They could. And what's really cool is that scientists recently found evidence of what looks like a recent volcanic eruption.
Wait, really?
Yeah. Using old data from NASA's Magellan mission from like the 90s.
You've got to be kidding me.
Yeah, they looked at the data again
Wow.
with fresh eyes. And they're like, whoa,
That is so cool.
I think there might be an active volcano here.
So this is a planet that's very much alive and active,
Very much alive. Not like Earth alive, but
not in a way that we would recognize.
right,
Yeah.
exactly.
Yeah.
But definitely active.
So what are they going to do to confirm that? I mean,
So VOM has an infrared imager,
okay.
which can detect heat.
Right.
So they're going to be looking for hotspots,
Like literally hotspots
literally hotspots,
on the surface.
to see if they can actually pinpoint where these active volcanoes might be.
Exactly.
Oh, that's so cool.
And then they can analyze the composition of the gases coming out
Okay.
to see if there's any water vapor in there.
Right.
Which would be amazing.
That would be a huge discovery.
Huge.
I mean, it all ties back to this question of how did Venus go from potentially habitable
Right.
to what we see today?
The hellhole.
The hellhole, yes,
Yeah.
that we know, and
Inferno.
the inferno
Yeah.
of today. And speaking of mysteries,
Yes.
we've got to talk about those mysterious dark patches in Venus's upper atmosphere.
Oh, yeah.
This is what everybody was talking about.
Everybody was talking about because it hinted at the possibility of microbial life.
Right.
Microbial life on Venus.
On Venus.
Yes.
I mean, what is going on there?
So these dark patches are still a mystery,
okay.
but they're really interesting because they absorb a lot of solar radiation,
Okay.
which affects the planet's energy balance.
So they're playing a major role in how Venus regulates its temperature.
Exactly. And some scientists think that these dark patches could be a sign of life.
Wow. Like, what kind of life are we talking about here?
So we're talking microbial life,
Okay.
like really, really tiny organisms. And the reason they think that is because they found phosphine in Venus's atmosphere.
Phosphine.
Well-
What is phosphine, and why is that significant?
Okay, so phosphine is a gas
Great.
that on Earth is often linked to microbial life.
Okay.
Like certain types of bacteria that live in environments without a lot of oxygen,
Right.
they produce phosphine.
So finding phosphine on Venus is kind of like finding a little calling card.
It's like a little, hey, what's up?
Yeah.
Eh.
From these potential microbes. Right. But it's not a slam dunk
Okay.
because there are other ways to make phosphine
Yeah, okay.
that don't involve life.
Right. Right. It's got to be some other chemical process or something like that.
Right. It could be geological.
Yeah.
It could be atmospheric.
Okay. We don't know.
So the mystery continues.
The mystery continues. But that's where these new missions come in
Okay.
because they have the instruments to actually figure out where that phosphine's coming from.
So VOM, Veritas, Envision, they're all going to be looking at this phosphine.
They're going to be looking at the phosphine. They're going to be looking for other molecules that are hanging out with it.
Like its little buddies.
Yeah. Because those little buddies can tell us a lot about where the phosphine came from.
It's like detective work on a planetary scale.
It is. It's like CSI. Venus.
I love it. So we're trying to figure out if this phosphine is a sign of life
Right.
or if it's something totally explainable.
Right. And even if it's not life,
Yeah.
finding out what it is still really important.
Because it tells us about how planetary atmospheres work
Right.
and how they evolve.
So Venus is like this giant laboratory.
It is a giant laboratory.
We're only just beginning to understand.
Exactly. And it's a reminder that we still have so much to learn
Absolutely.
about our own solar system.
Absolutely. So by analyzing these underground radar signals, scientists can start to understand what's going on beneath the surface.
Like, what's its geological history?
Right. Like, what has Venus been through?
Right. Like, was there a period where it was getting bombarded with asteroids?
Okay.
Or has there been a lot of volcanic activity?
So it's like we're piecing together this puzzle
It's like a puzzle.
of how Venus got to be Venus.
Exactly.
And we can't forget about the atmosphere.
The atmosphere.
We touched on it a bit, but that's a huge part of this whole story too, right?
The atmosphere is crazy. I mean, it's,
And VOM is going to be studying that as well?
yeah, they're going to be looking at things like water vapor.
Water vapor. Now, why is that important?
Well, remember we were talking about the possibility that Venus used to have oceans.
Right, right.
So if they can find evidence of water vapor being released from volcanoes,
Okay.
that gives us more clues about that whole idea.
So volcanoes could hold the key to Venus's watery past.
They could. And what's interesting is that scientists think that Venus might still be volcanically active.
Wait, really?
Yeah. They found some evidence using old data from NASA's Magellan mission
No way. From the 90s.
from the 90s. They looked at it again and they're like, huh,
That's amazing.
I think this might be a volcano.
Wow. So Venus is not a dead planet?
No, it's very much alive.
It's alive and well. And
Oh, it's alive.
it's alive, yeah.
Yeah.
Maybe not well.
Not well. No.
So how do they know for sure if these volcanoes are still active?
So that's where VOM comes in.
Yeah.
It's got this infrared imager,
Okay.
which can detect heat.
Right.
So they're going to be looking for hotspots.
Hotspots. Literally hotspots.
Literally hotspots, like on the
They're like, "Oh, this
surface
is-"
to see if they can find these volcanoes.
That's incredible. And then what happens if they find them?
If they find them, they can analyze the gases that are coming out
To see what they're made of?
to see what they're made of.
Okay.
And if they find water vapor,
Right.
that's huge.
That's a really big deal.
That's a really big deal.
Okay, so we've got this planet that might have had water,
Right.
might still have active volcanoes,
Right.
and then there's this whole other thing
Yeah.
about potential microbial life
The big question, is there life on Venus?
in the clouds.
In the clouds. Yeah. We talked about those mysterious dark patches before.
Right, that everybody was talking about.
Everyone was freaking out about.
Yeah, like what is going on there?
It's still a mystery,
Okay.
but what we do know is that they absorb a lot of the sun's energy.
So they're kind of like these giant sunshades almost?
Yeah, they're like Venus's sunglasses,
Okay.
and that affects the planet's temperature,
It's gotta.
like big time.
Yeah.
And some scientists think they could be a sign of life.
Okay. What kind of life? Like, are we talking little green men here?
Not little green men, more like little tiny microbes,
Okay.
like bacteria. And the reason they think that is because they found this gas called phosphine.
Phosphine. Okay, now break that down for me. What is phosphine and why is that such a big deal?
So phosphine is a gas that on Earth is often made by microbes,
Okay.
like these bacteria that live in really harsh environments
Right.
where there's not a lot of oxygen.
Okay.
They produce phosphine. So finding it on Venus is like,
Interesting.
interesting. Could be life,
Could be life.
but it's not a guarantee
Okay.
because you can make phosphine other ways too.
Okay. So how do we figure out if it's life or not?
That's where these new missions are really going to come in handy
Right, right.
because they have the instruments to actually figure out where this phosphine's coming from.
They can look for clues,
They can look for clues. They can look for other molecules that are hanging out with the phosphine.
like its little buddies.
like its little buddies,
Okay.
because those can tell us a lot about where the phosphine came from.
So it really is like detective work,
It's like a puzzle.
trying to solve this mystery of...
Is it life or is it not?
It's amazing to me how much information we can get just from studying a planet's atmosphere. I mean,
It's like a fingerprint, right?
yeah,
Every planet's atmosphere is unique.
right.
And it can tell us so much about that planet's history, its composition, its potential for life. I mean,
It's like a record almost
it is like a record.
of everything that's happened.
Yeah.
And we're just starting to learn how to read those records.
It's just scratching the surface.
It's incredible.
It is incredible. And you know what's even more incredible is that we're finding all these exoplanets out there.
Oh, yeah. I was just going to say, this is a good segue because,
Yeah.
we're talking about Venus,
Right.
but there's this whole other thing happening right now
Yeah.
where we're discovering all these planets.
All the time. Every day there's a new exoplanet.
Right,
Mhm.
around other stars.
Yeah.
And we're trying to figure out which ones might be habitable.
Exactly. And that's where studying Venus comes in,
Okay.
because it teaches us what to look for
Right.
and what to avoid.
Right.
Because for a long time we thought, oh, if a planet's in the habitable zone,
Right.
it's good to go. Right.
Right. The Goldilocks zone.
Yeah, the Goldilocks zone. Not too hot, not too cold. But Venus is like, whoa, hold on a second.
Yeah.
There's more to it than that.
Right. It's not just about where you are in relation to your star.
Yeah.
It's about all these other factors.
All these other factors like your atmosphere, your volcanic activity, even your rotation.
Well, and speaking of rotation,
Yes.
Venus has a very strange rotation, doesn't it?
It's like the laziest planet I know.
It's like spinning in slow motion.
I know. A day on Venus is longer than its year.
That just messes with my head every time I think about it.
It's crazy. And we don't even know why it spins so slowly.
Yeah. It's a big mystery.
Big mystery. Some scientists think that maybe it got hit by something early on.
Like another planet.
Yeah, like a big asteroid or even another planet.
Yeah.
And that kind of knocked it off kilter.
So it's like a cosmic hit and run.
A hit and run.
And Venus is just like
Still reeling.
reeling to this day. That is wild.
It's wild.
So what are we going to learn about that from these new missions?
Well, they're going to be studying Venus's rotation in more detail,
Okay.
trying to figure out, like you said, how fast is it spinning? Why is it spinning this way? Has it always been this way? All these questions.
So we can learn a lot about how planets form and evolve.
Exactly. And it's not just about Venus.
Wow.
What we learn there, we can apply to other planets.
Other planets around other
Well,
stars.
exactly.
And that's really what it's all about, right? I mean, it's about understanding our place in the universe.
Our place in the universe, and the fact that we can even study these things.
Yeah, I know.
It's incredible.
so far away.
I know.
Eh,
It blows my mind.
It's mind-blowing.
It really is.
Well, on that note, I think we've done it again. We've taken our listeners on another deep dive into the fascinating world of Venus, this mysterious, hot, intriguing planet.
It's a wild place.
It is a wild place, and we're learning more about it all the time.
We are.
So thank you for joining us on this journey, and until next time, keep looking up.